Hello guys, my name is Nikander. I'm a professional blockchain developer, and in this guide I'm going to show you how to test your smart contracts without deploying them on the blockchain. Let's get started. In the previous lesson we have created a simple counter contract, built it, deployed on Ton testnet chain and interacted with it. Let's see the code in more details to refresh it in our memory. First, we have created the counter smart contract. We have defined two variables, ID, an integer that uniquely identifies the instance of the contract, and counter, another integer that used to keep track of a count, initialized to 0 and incremented by incoming messages. Init constructor, which is called upon its creation, it takes one parameter, the identifier for the contract instance. Two getter functions are used for retrieving the counter and ID values. Message type named add represents the idea of what data we are awaiting inside the counter. Receive function is the main function of the smart contract. It handles incoming messages of the type add. When an add message is received, it increments the counter state variable by the amount specified in the message. Inside the deploy script, we generate a random integer and use it as a unique identifier for the contract. Send a transaction to deploy the contract. The sender of the transaction is provider.sender. The value transferred with the deployment is 0.05 Toncoin, converted to nano units using toNano function. Additional transaction parameters: type set to deploy and query ID set to 0. Wait for the deployment to be confirmed on the blockchain using the contract address. Log the ID to the console to confirm the successful deployment and initialization. The increment counter script used for interacting with the deployed contract. First, we initialize a counter contract instance by parsing a blockchain address and opening it for interactions. Fetch the current value of the counter from the blockchain and log it. Send a transaction to the blockchain to increment the counter. It specifies the sender of the transaction, the amount of the token to send with the transaction, additional parameters for the transaction indicating the type of action, add, a unique query identifier of 0, and the increment amount 1. Then we enter a loop to wait until the counter value on the blockchain updates. If the counter hasn't changed, it logs an attempt message, waits for 2 seconds, and checks the counter value again, incrementing the attempt counter each cycle. Finally, once the counter value has changed, we log the updated counter value. In the previous lesson, we interacted with our smart contract by deploying it on the Ton testnet chain. Today we will see how to test our contract without deploying it on the real chain. I'm going to copy the previous lesson project to the new folder called Lesson 3, but you can work with the existing project if you want. First, let's navigate to the counter project directory. Open the script inside the tests folder. As you can see, we have an error. It says an argument for ID was not provided, because we need to provide an initial counter value. Let's use 0. First, we declare variables to store instances of the blockchain, a deployer contract, and the counter contract. Before each defines a function that runs before each test in this suite. Instantiate a new sandboxed blockchain environment. Deploy the counter smart contract with an initial counter value of 0 and open it for interaction. Retrieve a treasury contract instance named deployer, used for funding transactions in the sandbox environment. Send a transaction from the deployer to deploy the counter contract. Check if the transaction history includes a successful deployment transaction from the deployer to the counter's address. Define a test case that implicitly verifies deployment success by its setup in before each. I haven't changed the changes we made with initiation. Let's run the test and see what we get. Type npx blueprint test. Our test failed. We got an error. An argument for ID was not provided. Let's save the changes and run the test again. Great! Our deployed test is successfully completed. Now we can add additional tests to our script. Begin a test case to check that the counter can be incremented. Define a loop to perform the increment action multiple times. Log the current increment action and count for visibility. Retrieve a different treasury contract for each increment to simulate multiple users or transactions. Fetch and log the counter value before the increment. Generate a random value for the increment and log it. Send a transaction to increment the counter by the random determined value. Check if the transaction was successful based on the transaction log. Fetch and log the counter value after the increment. And the final check. We need to be sure that the final counter value equals to the initial value plus the increment, ensuring the contract functions as expected. Now we can run the test npx blueprint test. Great! Our two tests have passed successfully. As you can see in the logs, our smart contract increments randomly generated numbers without any issues. Two tests are completed without errors. Now you can test your smart contracts without deploying them on the real blockchain. That's great! That's it for today. Thank you folks for watching the video. Don't forget to like and follow for more content like this. See you in the next video.